Okay, so in this video, we're going to go over finding a slant asymptote. Now, one thing to keep in mind is that not all rational functions have a slant asymptote. The functions that do have what is called a slant asymptote is a function whose degree in the numerator is exactly 1 degree higher than the polynomial in the denominator. Okay, so we notice here we have degree 3 in the numerator, and then here degree 2. Right, so the numerator is +1, and that satisfies the condition for the function having a slant asymptote. Excuse me. Okay, now how do we find it? Okay, so luckily it's something that we've done in a previous section by doing some long division. So here I'm going to do 3x plus 4, and here we have 6x cubed minus 5x. Okay, and again, as a reminder, the way we do that is we just look at the leading term here, right? So what's missing? We need a 2x. Okay, and then that becomes what, 6x cubed plus 8x. We subtract here, so we get negative 13x. Okay. All right, so that is our remainder. I can't go any further, right? That's x squared, that's x, so that is that, right? Now, again, the reason, so we can rewrite kind of from before, f of x here, and we get 2x minus 13x over 3x squared plus 4. All right, that's our remainder. All right, so as it turns out, right, for this slant asymptote, this is a type of end behavior. So what happens is we look at what happens as x goes to infinity or as x goes to negative infinity. All right. Now, in both cases, this remainder here is going to go to 0, right? If we look at the leading terms here, it's bigger in the denominator, so it resembles that 1 over x. And you notice that from our toolkit function, both of those go to 0. So what we're left with is 2x. And again, here, this is for large values of x. And again, here, large in the positive and negative direction. Okay, so large in the absolute sense, in the absolute value sense, right? And this now becomes my slant asymptote. My slant asymptote here is the, excuse me, the dividend, right? So my slant asymptote is y equals to 2x. Okay, so whenever you perform your long division, right, whatever the dividend here is, that's going to be your slant asymptote. I just wanted to go over why it is that this works. And let me show you here. Right, looking at this graph, what we have the graph here. There's most of my rational function. Now I'm going to graph along with that my slant asymptote, y equals to 2x. Right, and you notice here, as I zoom out, right, again for my end behavior, if I zoom in there, right, it possesses that similar behavior, right, in both directions. All right, not at first, right, the local behavior is different, right, but that's not what I'm after, right? The slant asymptote is interested in my end behavior. Okay, so that's how you calculate the slant asymptote, and again, this is only when the degree of a rational function is larger by exactly 1 in the numerator. Okay, thank you.